Hello.
안녕.
Hi.
Namaste.
Ni hao.
Hola.
Good day.
I'm teacher Iza. I'm teacher Putry.
I'm teacher Rashida.
I am teacher Hidayah. I am teacher Aina.
I'm teacher Afika.
How are you today?
Welcome to this class. What are we going to learn today?
We are going to learn hypothesis test involving single population mean.
Are you ready, students?
If you guys are ready,
Let's get started.
Hello. Oh, what's this? Hypothesis testing. Hypothesis is what we had at school, right? You know, the science, subject science, so the hypothesis, and then you do the experiment in the lab, and then you get the result, and you compare it with the hypothesis you did before, that kind of things. Okay, but hypothesis testing is an act of statistics whereby an analyst tests an assumption regarding a population parameter. So it's kind of different, okay? So in statistics, we're not going in the lab, do some experiment, but we use such method that we do a survey from a population, take some sample, get some data, do some investigation, and ensure that the claim, the hypothesis, is right or wrong, okay? Also in statistics, we will read some problems, some situation, find out the hypothesis, what it is interested about, and by then you know what test you will need, because hypothesis testing have various methods, have various tests, okay? So in find out what tests you might need, you have to first find out the hypothesis. So actually you have to find two hypotheses, which is null hypothesis and alternative hypothesis. So hash small 0 is what we call null hypothesis. So null means generally zero, empty. So null hypothesis is a statement about the value of population parameter. Okay, it's kind of like a default hypothesis thing from a previous study, but then some person came up and say no, the hypothesis is not accepted nowadays. So I want to come up with a new hypothesis and I want to test out again. And that's what we call alternative hypothesis, a statement that is accepted if the sample data provide evidence that the null hypothesis is false. Okay? But there are always some of null hypotheses which people consider true based on the previous study. So it doesn't mean that the null hypothesis is always false and alternative hypothesis is not always true. Okay, so I'm going to show you some example. Wait a minute. Oh, now I get the question here. Okay, this is not like a question. This is a situation where a report released some years ago stated that a typical family spent an average of 20 ringgit per day on food. Suppose a recent study on a sample of 50 families found that they spend a mean of 25 ringgit per day on food with a standard deviation of 5 ringgit 50 cent. We are interested to know whether the true population mean is now greater than 20 ringgit. Okay, so this statement here, okay, average 20 ringgit is what we called null hypothesis, because some years ago it means this is a study, this is a previous study years ago. But then I and you are interested to know, so we say that no, it's not 20 ringgit, it's right now greater than 20 ringgit. Okay, and that is what is alternative hypothesis. So after we find out the two hypotheses, by that you will know what kind of test you might going to use. And after you run the test, by then you will get these two possible outcomes, which is whether you will reject the null hypothesis or you will accept the null hypothesis. Okay, so in this statistical testing, actually there are four possible situations here where after you decide the outcomes there, your decision there, you might get your decision is true and might be in error. Okay, so I can summarize this in the table here. You see some correct decision and type 1 error, type 2 error. Okay, so type 1 error is what it occurs when the researcher rejects a null hypothesis which is actually true. So the probability of committing this error is what we call alpha, the level of significance. Okay, for the type 2 error, okay, so the type 2 error occurs when the researcher accepts the null hypothesis which is actually false. Okay, the probability of making this mistake is what we call beta, otherwise it's a power of 10. Okay, I think you not understand much, but I'm going to show you some example, the situation, so you see more how this errors work. Okay,
let us take this example where Wani had mild symptoms of COVID-19 and she decided to get tested. There are two errors that could potentially occur. Type 1 error happened when the test result says Wani have coronavirus, but she actually don't. While type 2 error happened when the test results say Wani don't have coronavirus, but she actually do.
That's how the errors work. So it's like you accepting the false one and you reject the true one. So I think that's all from me for today. So I'm going to pass on to my friend Afika. So she's going to explain more on hypothesis testing.
So today I will explain for the step in hypothesis testing. In hypothesis testing, there are 5 steps, which are: first, we need to set up the hypothesis. We need to find the null hypothesis and the alternate hypothesis from the equations. Next, in step 2, we need to set up the test statistics such as z-test, t-test, f-test or chi-square test. And follow with the step 3, we need to use the significant level to find the critical region. So in these questions, they will state the percentage of the test, and then we estimate the values of population parameters by referring to the table of statistics. Next, we go to the step 4, which are computations. In computation step, we need to calculate null hypothesis by using the test statistic that we had choose in step 2. But last but not least is in step 5, we need to provide the decision which compare the test statistic between population parameters in step 3 and test statistic from simple data in step 4, and then we conclude the answer of the questions. Let's move to more details. So in step 1, we need to set up the hypothesis. We need to identify the null hypothesis and the alternate hypothesis in the questions. And then we need to identify the tildes for the hypothesis, which are, we have left tildes, where the critical region is on the left side of tildes, and the right tildes, which are the critical region is on the right tildes, and the hypothesis for two tails, where we can see that the critical region is on the both sides, which are right and left tildes. Next, in step 2. In step 2, we need to state the test statistic. Test statistic that we choose will be used in calculation in step 4. So, this is the example for test statistic that we usually use, which are z-test, t-test, t-square test, and the f-test. So, and the next column is the formula that we will use to find for each test. Next step is to find the critical region by using the significant level. In step 3, we need to estimate the values of population parameters to find the critical region in the table. So from the questions, they will provide the significant level such as 0.01 significant level. And then we need to find the population parameters by referring to the statistical table. So in z-test, we will refer to the table in table 4 in the statistical table, t-test in the table 7, chi-square test in the table 8, and the f-test in the table 9. In step 4, which are computation steps. In computation step, we need to calculate the test statistic that we had choose in step 2 by using the sample data. This is the example for calculations that we have. Mu is equal to 12, the sample size, which are n, is equal to 50, and the standard deviation is 0.5, and the mean is equal to 11.8. So under the null hypothesis, it shows that mu is equal to 12. So in this example, we use z-test statistic to find the answers, and then we get the answer is negative 2.83. So for the last step, we need to find the decisions and conclude the conclusions. In step 5, we need to compare the test statistic between population parameters that we found in step 3 and the test statistic from sample data in step 4. So we compare the answer to find the rejection of null hypothesis. Either we reject or we fail to reject the null hypothesis. So this is the example on how you can write the conclusions. So since the negative 2.83 is lower than negative 2.53, we reject H null at 0.01 significant levels. It shows that the null hypotheses are not true. Here is the summary step in hypothesis testing from step 1 until step 5.
Alright, now we continue to the case and the example for this hypothesis testing for mean. So, as for case 1, we have variance is known for this hypothesis testing. First of all, we need to know two things before starting the analysis of the question, which are the value of variance and sample for the question given. Now, in this case, which is by central limit theorem CLT, the test statistic to be used is the z-test, which is the formula for z-test is sample mean minus mean over sample standard deviation divided by square root n for sample. For your information, it is a normal distribution. In this formula, then we have three types of null hypothesis, which are the two-tail test, lower tail test, and upper tail test. This formula for null hypothesis is all equal to mean, but alternative hypotheses are unequal to mean, less than mean, and more than mean. As you can see in A, alternative hypothesis is not equal to mean. This means that we have a two-tail test. So, in the two-tail test, we need to find the positive and negative region of A over 2, and then we can conclude that either the mean needs to reject or fail to reject. Now, we move to the formula in B, which is the lower tail test, that is less than z-test. So, for the lower tail test, we need to find the negative region of A. Also, at the end, we can conclude that it is needed to reject or fail to reject too. Last, for case 1 is the upper tail test, which is more than the z-test. As for this upper tail test, we need to find the positive region of A, and after comparing the z-test, we can conclude to reject or fail to reject the mean.
Students, pay attention! Now, I would like to give a question example of case 1. Here is the question. A factory has a machine that dispenses 80 ml of fluid in a bottle. An employee believes the average amount of fluid is not 80 ml with a standard deviation of 2.5. Using 40 samples, he measures the average amount of dispensed by the machine to be 78 ml. Question A. State the null and alternative hypothesis. And B. At a 0.01 level of significance, is there enough evidence to support the idea that the machine is not working properly? When we read the question, we must read until we understand what the question wants and what the topic question asks. Since there is a words like belief and the question A asks the hypothesis, so the question fall in the topic fall. Besides belief, there is also has another keywords like claim, stats, and many more. After we understand the question, we highlight all of the useful keywords or information. In this question, we're gonna highlight a machine that dispenses 80 ml of fluid in a bottle, and an employee believes the average amount of fluid is not 80 ml. This shows you the hypothesis statement. Next, we highlight the standard deviation of 2.5 and take up the standard deviation like this to make you easy to see. After that, using the 40 samples show you the sample size, so you write it back at the below. The last one is highlight the average amount dispensed by the machine is to be 78 milliliters. This information tells us the mu or the mean of the machine. After we have taken all the information out, we need to proceed to question A. So the question A, we state the null hypothesis, H null, mu equal to 80 ml. And the alternate hypothesis, the H1, mu is not equal to 80 ml. So we have done the A part. Next, we proceed to the question B. From the question, we are given that the alpha value of 0.01. So the question wants us to clarify the hypothesis that the employee claims is to be true or not. Just now, we have proceeded the step 1 and stating the hypothesis, right? So now, we can proceed to the step 2, which is stating the test statistic. Since this question was given the standard deviation of the population, so we're going to apply the z-test since the standard deviation is known. After that, step 3. using alpha 0.01 to find the critical region from normal distribution table. Since the test is the two-tailed test, so we're gonna look at the both sides of the distribution. First, Z alpha divided by 2 equal to Z 0.005. We look up the distribution table. We search the value of alpha 0.005 is located to somewhere. And we get to 2.5058. After that, the left tail test. We're gonna write the negative Z 0.005, and since the graph is symmetrical on the both sides, so the value gonna be the same. Just add the negative value in front of the value, so it will be negative 2.5058. Now, to make it clear to see, you can draw the normal distribution on the left side or the right side, so we can figure the rejection area. Next, step 4 is computation. We will calculate the z-test that we have decided in the step 2. Just apply the formula and insert all the information that we get just now. So 78 minus 70 over 2.5 over Z40. Then we press the calculator and we get negative 5.0596. Now the last step. In the step 5, we need to make a decision and conclusion. So we must compare the computation amount with the normal distribution amount that we have calculated just now. Now the decision will be, since negative 5.0596 is less than negative 2.5758, so we reject H now at 0.01 significance that the main amount of liquid is not equal to 80 ml. Okay, that's all. We have finished the question example. You may try by your own next time.
We move on to the case 2, which is the variance is unknown and the sample n is more than 30. In this case, also the test statistic to be used is the z-test, which is the formula for z-test is sample mean minus mean over sample of standard deviation divided by square root n for sample. As you can see here, all these formula are same in the case 1 because they still use the statistic test for the z-test. So, for picture in A, the alternative hypothesis is not equal to mean. This means that we have two-tailed test. So, in the two-tailed test, we need to find the positive and negative region of A over 2, and then we can conclude that either the mean needs to reject or fail to reject. Now, we move to the formula in B, which is the lower tail test, that is less than z-test. So, for the lower tail test, we need to find the negative region of A. Also, at the end, we can conclude that it is needed to reject or fail to reject too. Last for case 2 is the upper tail test, which is more than the z-test. As for this upper tail test, we need to find the positive region of A, and after comparing the z-test, we can conclude to reject or fail to reject the mean.
Assalamualaikum and hi, I'm teacher Rashida. Next, we are going to do question for case 2. So let's do it. The question is, among 157 African American men, the mean systolic blood pressure was 146 millimeter of mercury with standard deviation of 27. We wish to know if on the basis of this data, we may conclude that the mean systolic blood pressure for a population of African American is greater than 140. Use alpha 0.01. From this question, we can know a few information. What information we can get from this question? The information is sample size is 157. Next, the mean systolic blood pressure is 146. For standard deviation is 27. And lastly, the alpha is 0.01.
My tip is, before we do the solution, we must take note the important information from question to know if case either case 1, case 2 or case 3. From this information, the variance is unknown and the sample size is more than 30. So it in case 2. The first step for solution, we must set up the hypothesis. From the question, it states that we may conclude that the mean systolic blood pressure for a population of African American is greater than 140. So, for null hypothesis is equal to 140 and alternative hypothesis is more than 140. Next, we go to step 2. For step 2, we must take in the test statistic. Since the variance is unknown and the sample size is more than 30, we must use z-test. Here is the formula for z-test. Okay, now we at step 3. We are going to use alpha 0.01 to find the critical region. For Z 0.01 is equal to 2.3263. Where I get this value? It's from statistical table. If our z-test is less than 2.3263, we fail to reject null hypothesis. But if our z-test more than 2.3263, we reject null hypothesis. So let's do step 4. Step 4 is computation. At this step, we are going to calculate the z-test. So 146 minus 140 divided by 27 divide square root of 157. After we calculate, we get the value 2.7844. And lastly is step 5. In step 5, we are going to do discussion and conclusion. Since 2.7844 more than 2.3263, we reject null hypothesis at 0.01 significant level. Hence, we may conclude that the mean systolic blood pressure for a population of African American is greater than 140. So, that's all from me. Thank you.
Last for this hypothesis testing of mean in case 3. In case 3, we know that the variance is also unknown, but the sample n less than 30. In this case, by the central limit theorem CLT, the test statistic to be used is t-test, which is the formula is the sample mean minus mean over a sample of standard deviation divided by square root n for the sample. And it is also follow a t-distribution with n minus 1 degree of freedom. As you can see here, all these three formulas are the same as the other case, but the different one is they use the statistic test for the t-test. So for picture in A, the alternative hypothesis is not equal to mean. This means that we have two-tail test. So in the two-tail test, we need to find in positive and negative region of A over 2, and then we can conclude that either the mean needs to reject or fail to reject. Now, we move to the formula in B, which is the lower tail test, that is less than t-test. So, for the lower tail test, we need to find the negative region of A. Also, at the end, we can conclude that it is needed to reject or fail to reject too. Last, for case 3 is the upper tail test, which is more than the t-test. As for this upper tail test, we need to find the positive region of A, and after comparing the t-test, we can conclude to reject or fail to reject the mean.
I'm Young. Now let's look at an example for case 3. First, let's read the question first. A gas company claimed that the length of time between a gas leak being reported and an engineer arriving to investigate the report has a mean of 130 minutes.
A random sample of these times in minutes was 140, 112, 152, 85, 150, 70, 230, and 103. Using the 5% significant levels, test whether there is evidence that the mean time exceeds 130 minutes. Assume that the distribution of times is normal. Now, let's find information from this question. Now, let's count the list of random samples. 1, 2, 3, 4, 5, 6, 7, 8. So, n equal to 8. When n equal to 8, we can conclude that n less than 30. Since the question gives a list of random samples, we can get the variance from the random samples. That means the variance is unknown since we got it from random sample. Let's list the information first. Variance is unknown, n less than 30. Mu equal to 113, n equal to 8. Now, let's find the mean using the list of a random sample given. So we got mean 130.25. The alpha given is 0.05. Next, we must find the standard deviation. So this is the formula to find standard deviation. Now, we substitute value into the formula given. You can use a calculator to calculate it. So, the standard deviation is 50.2302. Next, the question asks us to using the 5 significant level to test whether there is evidence that the mean time exceeds 130 minutes. So, the rejection region on the right tail test. We can write H1 mil more than 113 because the question mentioned exceeds 130 minutes. We're gonna use t-test. We can conclude reject H null if t more than t alpha n minus 1. Now, since we have enough information, we can start solving this question. Step 1. We must set up the hypothesis. H null mil equal to 113. For H1, mil more than 113. Now, settle with step 1. Now, move on step 2. We need to determine an appropriate test statistic and distribution to use. Since variance is unknown and less than 30, we're gonna use, correct, t-test and t alpha n minus 1. Next, step 3. Use alpha 0.05 to find a critical region. So the formula t alpha n minus 1. Now we substitute the value a with 0.05, n equal to 8, 8 minus 1 equal to 7. Now we'll find the value on t distribution table. Table for t distribution is table 7. First, we find a 0.05 on top. Then we look degree of freedom 7 on left side. So the value for TA alpha 0.057 is 1.895 settled. Now we continue with step 4, computing the value of the test statistic using H null mil equal to 113. Then we need to calculate t-test using this formula. Now we substitute the value mean 130.25 minus mu 130 over standard deviation 50.2320 per square root n equal to 8. The answer is 0.971. The last step, which is step 5. We must make decision and conclusion. T-test, we got 0.971. Using alpha 0.05, we got 1.895. Rejection when t-test more than critical region. Since 0.971 less than 1.895 failed to reject H null at 0.05 at significant level, the mean time not exceeds 130 minutes. Finish! That's all for example case 3. Thanks guys!